In my previous video on creating transition shaders, there were a few things I neglected to mention. Two of those things may lead to some unexpected behaviour, so in this video I'm going to be going over those, as well as a third change that should help reduce the need for some hacky workarounds in certain implementations. If you haven't seen the first part, take a look in the description and you'll find a link to it there. The first issue that people may run into is using the current scene property of the scene tree. If you need to access the current scene property that is available when using the getTree function, using the scene manager we previously created will not update this property and will instead return a null reference. To demonstrate this problem, I'll update scene.gd to print the current scene property of the scene tree so we can monitor the output window as we transition between scenes. We can see that when our initial scene is loaded, the content of the property is scene 1, as we would expect. Now, when we transition to the next scene, we can see we no longer have a valid reference. This is because we are loading in our scenes manually, as opposed to using the change scene to file or change scene to packed functions that are provided by Godot. To work around this limitation, we can add our own field to Scene Manager to track the current scene instead. First, let's define a new property called current scene and assign it a setter function. In the setter function, we're going to check if current scene has been assigned a value yet. If it hasn't, we'll assign it and exit the function. If, however, current scene does have a value assigned already, we'll instead assign the new value and then use the same code that we previously added to the transition to function to handle loading the new scene inside the setter function instead. Next, we'll add the ready function to initialize the current scene property when our game is initially launched. The last change that we need to make is in the transition to function. We're going to highlight the code that we just added to the setter function and replace it with an assignment to our newly added property instead. With that change made, if we now go back to scene.gd and instead print the content of our implementation of current scene, we can see that the initial scene is correctly logged, and if we transition to the next scene and back again, we can see those are correctly logged too. The next thing that we're going to refactor is something that will almost certainly cause an issue if you're targeting PC users, which is the overlay consuming the mouse events. This really should have been in the first video, so thanks to Flynn's Army for letting me know that it got missed in the comments. As our overlay object in the scene manager is going to be above everything else in the scene tree, even if we're not rendering it, it will consume any events relating to the mouse clicks and movements. For any games that use the mouse as an input device, or any scenes that contain menu items, this will be a huge issue. Thankfully, it is very easy to resolve this. First, head over to the scene manager scene, and with the overlay object selected, open up the mouse section in the inspector. In the filter drop-down menu, there are three options we can choose. The default option that is selected is stop, which will allow the control to process the mouse events. However, there are no events that the overlay object needs to handle, so instead, we'll set it to ignore, which will prevent any events being passed to it at all. With that property set, that issue's fixed. The last change is an enhancement rather than fixing a bug. When we initially implemented the transition to function, we added some code to wait for the loaded signal to be emitted so that we can handle any background loading before we transition to the new scene. The issue with that is that there are going to be times when there is no background loading required, such as transitioning between menu screens that have no large resources to load. There were ways to work around this, like adding a timer that triggers on the next frame to emit the signal, but that's a pretty hacky solution. It's better to just update the interface to have a better design. The first change we need to make is in the scene script. We are going to add a new variable named emits loaded signal, and we will default it to true. As the name suggests, this variable is going to allow us to define whether or not a scene will need to do any background loading that must be completed before we transition to it. Next, we're going to open up the Scene Manager script and head down to the transition to function. We're going to change this so that we only wait for the loaded signal if the new scene emits the signal as defined in the new variable. Now to test this, we'll head to scene 1 and disable the signal emitting there. And in scene 2, we'll leave it enabled. When we transition from scene 1 to scene 2, you can see it waits as it did previously for the background loading to be completed. But now, when we transition to scene 1, it transitions immediately after invoking the load scene function. So that's it for this video. As always, let me know if there's anything you think I missed, what you liked, what you didn't like. There were a few hiccups with the audio quality in this video, so it'd be great to hear if you felt it was a problem or not. Let me know in the comments, and I'll see you in the next one.